And for our second example of our power series, solving differential equations, we have y double prime plus 4y is equal to 0. And we still have the same values of our y prime and y double prime. And now substituting the values of our y and y double prime into our equation, we have y double prime is equal to the summation of n times n minus 1 a sub n t raised to n minus 2, where n is equal to 2, plus 4 times the summation of y, where a sub n t raised to n, where n is equal to 0 as it approaches infinity. And after substituting the values of y and y double prime in terms of summation equation, we have our expression summation of n, quantity n minus 1, a sub n t raised to n minus 2 plus 4 times summation of a sub n t raised to n, where n is equal to 0, and y double prime has n is equal to 2. And shifting our expression in order to balance our index, we minus 2 to our t raised to n, and having minus 2 to our n t, we also minus the value of n. That's why it's equal to 0. And in order to balance our equation, we add up to our equation inside the summation. So from n, we have now n plus 2 and n minus 1. So it must be n minus 1 and a sub n plus 2t raised to n. And now we can observe that we have eliminated our 2 here, and we have added positive 2 here, where n is equal to 0 now. So we have balanced our equation by shifting our index, and to our y, for y, still the same, where n is equal to 0. Now, our main goal here is to have same indexes or values of n in order to evaluate our expression, because we can evaluate our expression if our index or our n is not equal to 0. Because remember, we're having power series in which n implies the number of terms or the values it was in the series. So it is important to have the same values of n as it identifies the corresponding terms in a series. And after having substituted the values of y and balancing our expression, which is equal to 0, we can now have factor our expression. We can factor t raised to n is equal to 0. So we have quantity n plus 2 times n plus 1 times n a sub n plus 2 plus 4an quantity t raised to n. And having our recursion relation, we have a sub n plus 2 is equal to negative 4 over n plus 1 times n plus 2 and times a sub n, where n is greater than or equal to 0. And the substituting values of n to our recursion formula of 1, 2, 3, and so forth, we have a sub 2 is equal to negative 4 over 2 AO, and a sub 3 is equal to negative 4 over 6 A1, and our A4, which is equal to negative 4 over 3 times 4. And since we have the value of a sub 2, we substitute the values here, where a sub 2 is equal to negative 4 over 2 times a sub o. We substitute it to our a4 in order to come up to the same variables of ao. So we have a4 is equal to 2 raised to positive 4 over 4 factorial ao. So we can observe the common factors of each terms. And a5 is equal to negative 4 over 5, 4 over 4 times 5, a3. And since we have the value of our a3, which is negative 4 over 6, a sub 1, we substitute the value of a3 here, having 2 raised to 5 over 2 times 5 factorial, and having a 1 here. So we can observe that we have common factors of a sub o and a sub 1. We can observe that in